All right, number 12, if the function is 1 to 1, find its inverse. If not, write not 1 to 1. And we've been given f of x equals x cubed minus 3. Now, number 12, not as straightforward as number 10 and 11, the previous two we looked at, because recall with 10 and 11, our function was simply a basic linear equation, right? And we know right away that linear equations, are 1 to 1, unless, of course, it's a horizontal line. But all other standard linear equations are 1 to 1. But in this case, we have x cubed minus 3, so we definitely want to take the time and use f of a equals f of b to see definitively whether or not we've got ourselves a one-to-one function on our hands before we attempt to find the inverse. So that's what we're going to do here. We are going to, and I seem to have lost it, there it is. All right, so we want to say f of a equals f of b. All right, well, to set this up, we need to first find f of a, and then we need to find f of b so that we can set these two things equal to each other. So f of a is simply going to take our given function here and swap out the x for a. And so what will that look like? Well, we'll take out x, put in a cubed minus 3, and there we have f of a. How about f of b? Well, very similar. We're going to take the original function, take out the x, put in a b, and so we have b cubed minus 3. And now that we've found f of a and we've found f of b, let's set these two things equal to each other, clean it up, and see if we can get a equals b at the end. So we'll say a cubed minus 3 equals b cubed minus 3. All right, let's add 3 to both sides. And the 3's cancel on both sides, and we're left with a cubed equals b cubed. We're trying to get to a equals b, so let's get rid of these cubes. Let's clear the cubes, and to do that, we'll take the cube root of both sides. And because we're dealing with a cube root, a radical with an odd index, we don't have to worry about plus and minus like we do when we are working with a radical with an even index. And so when we take the cube root of both sides, we do indeed get a equals b. So we know that f of x equals x cubed minus 3 is 1 to 1, which means an inverse exists, which means we can proceed to finding that inverse using the steps here to the right. So I'm going to go ahead, and now that we know this is 1 to 1, we'll clear that work and begin. Again, first step, really, we want to rewrite our f of x notation as y. So we get y equals x cubed minus 3, and now we can begin our three-step process. Step number 1, interchange x and y. So that simply means just swap x and y. And so we'll have x equals y cubed minus 3. Step 2 is now to solve for y. So here at this equation, x equals y cubed minus 3, we want to get y all by itself. So we will add 3 to both sides. And here on the right, the 3 goes away. And I'm going to go ahead and flip the equation. So I'm going to write x cubed on the left, x cubed equals, and x plus 3 on the right. We're used to solving for the variable on the left, and so I'm going to go ahead and do it that way. Well, we want y all by itself. We're solving for y, so let's go ahead and get rid of that cube by taking the cube root of both sides. And when we do that, we end with y equals the cube root of x plus 3. And so we've now solved for y. Y is all by itself, but our final step is step number 3. Replace y with f inverse of x notation. So we'll say f inverse of x equals, and the cube root of x plus 3. And there we have it, number 12.